Figures 7.16 through 7.18 gradebook using an array to store grades. In this example, we're going to show you how to initialize a gradebook object with an array of grades and then use that array of information to display the class average. And actually, let me go ahead and run this program first so you can see it in action. And basically, you can see that we're going to display our welcome message. We're going to show you the list of student grades for students 1 through 10, and these are the grades that are being supplied in the main function or created in the main function. Then we're going to display the class average, the lowest of the grades, the highest of the grades, and also a grade distribution chart, a bar chart if you will, showing you the number of grades in each range of values. So we've got a number of different things that we'll be showing to you in this program. So let's take a look at our main program first to see how we use Class Gradebook. Then we'll show you how we modified the class to allow ourselves to store an array of grades within the gradebook. So here, first of all, at line 4, we include the gradebook class definition from the gradebook.h header file. We'll look at that next. In main, we've created an array of grades called grades array, and we've pre-initialized it with 10 grades. And we'll take a look at this constant in a moment in the gradebook class, but basically within the scope of the gradebook class is a publicly accessible constant called students that represents how many students there are in the class. And for this gradebook, we've hard-coded it to have 10 students for the purpose of this demonstration. Once you learn how to do dynamic memory allocation, you could potentially have a gradebook that can store any number of grades. And actually, once we get to the end of this lesson and introduce the standard library class called vector, we could use that instead, and that would be a dynamically growable array, if you will, of grades that could have any number of students associated with it. So first we create this grades array. We'll talk about this constant again in a moment. Then we create our gradebook, giving it the name of the course and the array of grades as initializer values for the gradebook. So we're going to obviously modify the constructor for class gradebook to receive an array of grades. Then we tell the gradebook to display the welcome message and then to process the grades. And of course, we saw in this output that we're processing the grades by showing you the class average, the lowest grade, the highest grade, and also a distribution chart of the grades as well. Let's take a look at our header file, which describes the gradebook class. And you can see here that class gradebook is a little bit more robust than it was in prior examples. First of all, in the public section, we have a constant static integer called students, which is initialized to 10. When you have a constant declared in a class and you want your client code to be able to access that constant value, first of all, you have to put it in the public section of your class. Second of all, you must declare it as const, which makes it unmodifiable. You must initialize it so that it has its initial value from the moment it is created. And you typically will also declare it as a static member of the class. And what this means is that there's exactly one copy of this variable no matter how many objects of class gradebook we create. Now we'll revisit this concept of static data members in much more detail when we get to the lesson called Classes, a Deeper Look. However, in this case, all we want to do is emphasize the fact that we have this constant available to the client code that specifies exactly how many students are supported by this gradebook. And when you have a static constant inside of a class, the way that the client code can access that constant is by specifying the class name, a colon operator, and the name of the constant, in this case, students. So going back to our gradebook header file, you can see that our constructor is now specified to receive a string and an array of integer constants. We still have our set and get course name member functions, and we still have our display message member function. But now we also have a process grades member function, and that's going to actually be the function that calls all of these other functions in this example. But we could also call them directly because of the fact that they are public member functions of the class. So we have the process grades function, which is going to call get minimum, get maximum, get average, output bar chart, and output grades, but we also could call these other member functions directly. Now, get minimum and get maximum by their names are basically telling you what they're going to do, getting the minimum and maximum grade respectively. Notice that none of these later functions has an argument. They're all operating on the data that's going to be stored in an object of this class. Get average, of course, will calculate the class average. Output grades, output bar chart, and output grades will display a bar chart of the grade distribution and the actual grade values, respectively. And separately, our private data still consists of the course name for the course, but now also consists of the array called grades, which has students' number of elements, and again, students is 10. So this particular example is hard-coded to process 10 grades. Now, the implementation details of our class have changed a little bit as well. And let's start by looking at our constructor, which is receiving the string called name, which represents the course name, and we're passing that to set course name. And it's also receiving an array of integer constants, which we're calling grades array. And all we're going to do is we're going to walk through that array one element at a time, assigning each grades array element to the grades array that's stored inside of the gradebook object. So each of the each of the parameters elements are being assigned to the internal grades array stored in the gradebook object, and that's how we copy, if you will, the grades that were first created in main into the gradebook object. Now, the set course name and get course name member functions have not changed, and the display message member function has not changed as well. So let's jump down to process grades, which is going to control the rest of our program. When process grades got called from main, the first thing it did was call output grades, which is another function in our class. And because process grades is in the scope of class gradebook, it can find output grades in the scope of class gradebook as well. Then we're going to display the class average with a precision of 2 and fixed point format. We're going to get the minimum and get the maximum grade, and then we're going to output our bar chart. So let's take a look at output grades first. And you can see here that we're simply going to just display the string the grades are, and then one student at a time, we're going to output the word student, the counter value plus 1, so we get student numbers 1 through 10 instead of 0 through 9. And we're going to output the grade value for that student. Going back up to our process grades function, the next thing we're going to do is calculate the class average. So let's look at our get average function, which you can see here at line 98. And of course, all it's going to do is total up the grades, which we've done previously, and it's going to return the floating point result of dividing the total by the number of students. And there's the students counter or constant variable being used a couple of times in this example. The next thing we're going to do again is get the minimum and get the maximum, and these two functions are very similar. Let's look at get minimum here. In get minimum, we make an assumption, which is that the lowest grade that initially is the highest value possible, 100. Our grade values are 0 to 100. Any grade that we compare to that is going to be that value or lower, and basically we walk our way through the array of grades, and one element at a time we say, is the current grade we're looking at less than the low grade? If so, let's assign it to the variable low grade, and by the time we make it to the end of the loop, the variable low grade contains the smallest value, which we then return. And we do similar operations here for get maximum, except for high grade we assume it's the lowest possible value to start out, so that each of the grades we compare to it will either be that value or greater. We walk our way through the array, and for each grade, if it's higher than the high grade, greater than the high grade, we assign that variable, element's value, to high grade. And then finally, we have our output bar chart. And for output bar chart, we've seen examples like this previously, but basically what we're going to do is we're going to sum up the frequency of grades in each distribution, 0 to 9, 10 to 19, 20 to 29, etc., and also for the category of perfect grades, 100 as well. And what you see here is that we're first creating a constant integer called frequency size, which is 11, and that's the size of the array frequency that we declare on the next line. And here we're showing you a little shortcut to initialize all the elements of array frequency to zeros. So remember, when you provide an initializer list, if there are fewer initializers in the list than there are elements in the array, all the remaining elements are set to 0 by default. Well, by providing an empty initializer list, what that does is it automatically sets every element of the array to 0 right from the get-go. So that's a nice little trick for quick initialization of an array of integers or numeric type to 0. The next thing we do is we walk through the array of grades, and for each grade value we use integer arithmetic to divide it by 10. So if I have a number from 0 through 9 and I divide it by 10, in integer arithmetic I get a floating point number, 0, 0.1, 0.2, 0.3, and when you do it as integer arithmetic it truncates that. So what we wind up with is 0 every single time for values from 0 through 9. If I divide a value from 10 to 19 by 10, I will get a number that is 1, 1.1, 1.2, 1.3, etc. But again, integer arithmetic truncates that. So what we are effectively doing is winding up with a value from 0 through 10 that is then used as the index into the frequency array, and we then add 1 to that particular element of the array. So if I have the value 100 as a grade, when I divide it by 10, the value that I get is 10, and I increment frequency sub 10 at that point. Then I have a little for loop that just produces the output with the identifiers at the beginning of each row, and a for loop that iterates one at a time and displays asterisks to represent how many grades were in a particular frequency range. So as you can see here, we've enhanced the gradebook class substantially with a lot of different member functions. Most of those member functions take no arguments because they're simply operating on the array of grades that was passed into the gradebook constructor and used to initialize the gradebook object. And it's very common that once you place data into an object, that the member functions you call can then simply operate on that data and may not ever need to receive any additional data to perform their tasks. It's also common for certain types of methods to receive data. Certainly set methods are always going to receive data so that they can take a value and place it into an object. So as you can see in this example, we have just a set course name and get course name to modify our string variable, but you could envision the possibility of providing set and get methods that could modify the grades array as well. And as we get into building more robust classes, we'll certainly take a look at more methods that receive parameters and more different types of set member functions or methods as well.